Modern artificial intelligence possesses incredible reasoning capabilities, but it exists as a disembodied brain, isolated from the physical world it analyzes. To actually accomplish anything, humans have to act as the physical interface. We prompt the model, wait for a response, and then manually copy and paste that output into the applications where work actually happens. In late 2025, an open-source weekend project called OpenClaw addressed this limitation by automating the connection between models and local systems. Developers have built a digital nervous system that connects an AI directly to the outside world, ending the period where these models were limited to text on a screen. To understand how it works, we have to clear up a common misconception. OpenClaw is not a new large language model. A large language model, or LLM, is the underlying algorithm that processes and generates text, like ChatGPT or Claude. OpenClaw is an independent structural framework that houses those models. Specifically, it acts as an orchestration layer. This local software bridge lives directly on your hardware, connecting the AI brain to your operating system. Sitting locally grants the model secure, direct access to your personal files and communication channels. AI moves from a stateless, web-based advisor to a resident operator that lives permanently on your machine. Standard AI models suffer from an amnesia problem. Every time you close a session or a browser tab, their context window is wiped clean, and they simply forget you ever existed. OpenClaw solves this with a persistent local memory architecture. The system writes your conversation history to local text documents. When starting new tasks, the agent pulls from the stack to build long-term context, learning your specific details without constant reprompting. Local, editable memory files are the foundation of agency.
An entity cannot act autonomously if it cannot remember who it is working for. Once the agent remembers its instructions, it needs a way to execute them. OpenClaw separates its capabilities into two distinct software categories: tools and skills. Tools are the raw, underlying permissions granted to the AI, permissions to read a file, execute a terminal command, or control a web browser. Skills are the modular instructions that teach the AI how to combine those raw tools to accomplish complex, multi-step digital workflows. In practice, this means you can send a quick WhatsApp message to your computer, which triggers the agent to autonomously read your unread emails, cross-reference your calendar, and draft the appropriate replies. Background scheduling allows the AI to work as a proactive digital employee, operating independently and notifying you only when a task is finished. Giving an AI the physical ability to execute code and send emails introduces massive security vulnerabilities. Autonomous software carries inherent danger. This requires strict sandboxing. Sandboxing is a security practice where software is strictly confined to a restricted, isolated environment to prevent it from accessing root systems or critical infrastructure. For irreversible actions, developers implement a human-in-the-loop protocol. This ensures the AI cannot spend money, delete primary databases, or post publicly without final manual approval from the user. AI with digital hands requires the same governance and monitoring as critical, high-risk enterprise infrastructure. The logic used to control a web browser or a local file system is, at its core, the same logic required to control a physical noder. This realization led to the emergence of ROSClaw. This is a specialized bridge software that translates OpenClaw's digital commands directly into the robotic operating system layer, or ROS, which is the standard middleware used to program physical robots. We are now seeing this framework integrated into advanced physical hardware, testing complex humanoids and 3D printed robotic grippers. A developer can type a natural language command into Telegram and watch a physical robot in a laboratory execute that physical labor in real time. OpenClaw is evolving into a universal translator. It takes abstract human intent and successfully converts it into concrete physical manipulation in the real world. What started as a viral open-source weekend project has quickly matured into a foundational orchestration layer for autonomous operation. Legacy computing requires humans to manually operate dozens of fragmented applications. This system replaces that friction with intent-driven execution. The endgame here is the personal operating system. This is a unified software layer where a dedicated digital employee manages the friction of execution entirely on your behalf. Whether organizing digital files or commanding physical hardware, the system reclaims human time by automating the mechanism of action.